We have here is the refrigerator door. If I zoom back out, and then right below it we have a freezer drawer. Now what's happened is the original pin has been wanting to fall out. I'll zoom down right here, and you can see over the years when it starts to loosen up, it rubs here and it's been rubbing a groove in it. All right, here's a picture of the real problem. Is the pin comes up through the bottom hinge, and 3/4 it's covered by this ledge here. Originally there was a little spot weld, and there was probably a larger washer they had over the top of it, but that spot weld failed, and now we're having to troubleshoot it by making new pins. All right, we're going to zoom in and take a quick peek here as much as we can. And that is the hole where the new pin's going to slide back up inside. So let's see if I can get this here from the bottom. And you can see it pushes up in there. And then we'll close the freezer door. And we'll come right on over here. And let's see if I can zoom in. I think we might be able to get the E-clip right on the top right there. And I know the sunlight's trying to kind of beat in on us. All right, here's a close-up comparing both pins. We have the original pin, which is a little bit shorter, and we have the new one on the left where we've actually put a groove in for an E-clip. So there you go. You can kind of see the new one and the old one. And I'm going to pause and I'll turn it back on here in a second. Before I actually put the pin in, I thought I'd show you guys exactly what we're going to do here. We're going to take the tip of the pin right over here, and there's a small groove that I've machined into the top. And we're going to take this E-clip and we're going to pin across the top. And that should prevent the pin from falling out again and hopefully make this fix permanent. Okay, there is the pin in with the E-clip installed. See if I can zoom a little tighter here. And that should keep the pin from, over zoomed a little there. There you guys go. Original pin failure, E-clip design failure, new design success. Okay, here are all three pins. The first one is the original. It had a little spot weld on the top and most likely had some kind of flat washer to act as a retaining mechanism to prevent the pin from dropping down, which means they assembled the hinge at the factory before they attached the hinge to the door. So this was never meant to be repaired without replacing the whole hinge assembly. Our first attempt used this pin here, and we used a large E-clip. And what we found as we opened the door, after about 20 to 30 cycles, the E-clip would work off the top of the pin. There is a very small groove there to retain the E-pin, but for whatever reason it wouldn't stay attached because of the rotation each time. So the third version, we did increase the height by about 0.010 of an inch. There's another small groove, and we're going to try a snap ring. Now the snap ring looks small, but the overall diameter is, the top of the pins are at 5/16 of an inch, so that's a 5/16 snap ring. If that doesn't work, I also have some spiral rings, which you basically, there's two layers, and you stretch them apart kind of like a spring, and you can twist them on, down, around until they pop inside the groove. What I don't like about them is the width. I wish it had greater surface area. So if all of these two options don't work with the snap ring or the coil ring, I think the next step would be to actually make a larger diameter washer and then put the snap ring on there. We'd make the ID of the snap ring exactly at 5/16, so there's just a perfectly smooth fit right over the top of the pin, and I think that would completely solve it. But today we're going to try to get the snap ring on, so we're going to set up and do that. and we will see how much problem it's going to be. So I don't know how successful we're going to be videoing this, because most likely I'm going to need to be right where the camera is trying to shoot. So we do have the pin pushed up. I'm going to pull the freezer drawer out slightly, which means I'm going to have to reposition the camera then. And that way I can push up on the pin as I try to put this over the top. The tricky part here is we are partially blocked by the door, and I just found the missing E-clip from earlier. It decided to make an appearance and pop on out. We just don't have any clearance here at all. So let's just see if we can get this in position and on. Okay, you're gonna have to ignore the annoying beeping. Got the snap ring pliers. I see our pin has already slipped out a little. So we're just going to try to work it up a little bit. We don't want it all the way through the top. We need a little room to get the Okay, you guys saw it. That's exactly what it does. It falls out just like that. All right. Here we go again. Good thing the bag has 10 clips in it. All right, after several minutes, I actually shut the camera off. About 7 or 8 attempts, I finally got the snap ring to go around the pin. I might have sprung it a little, so I may have to put a different one on, but we're going to run with this one and see how it works out. And if not, we'll go to version 3 to fix it. So we made some changes to the part design, and we're going to try an external retaining ring, or snap ring, which we don't know if we have the clearance to get that on. That may not work. Otherwise, we also have as another solution a spiral ring, which we can kind of spread apart and stretch onto the part. Either solution will work in the same groove width and groove diameter. So we're going to make this out of stainless steel like we did on the prior part. So the first thing we need to do is get ourselves turned down to the overall diameter of 496, slightly under a ½ inch. So I think what we'll do is we'll just get ourselves a rough mark here. It doesn't have to be super accurate. That way we have enough material turned down. If we make a mistake, we can go back and add it. So we'll make that as our little mark. All right, let's get a spot here and we'll start cutting. We're just going to get ourselves all of our measurements here. So we'll face off the front. We'll set up our dial indicator over here so we can keep track of the overall depth of cut, because we'll need that as we make reducing the different diameters here in a little bit. We're going to make a real light pass the very first time.
We're about 570. Let's take another 30 off and we'll check it again. So we're at 518 and we're looking for 496. So we got 22,000. So we'll make a light pass at 10 and then we'll check it out again. All right. The next thing we need to do is turn over the next major diameter, which is 375. And we are going to turn that back for 0.867 inches. All right, so we're going from 500 to 375, 125 thousandths total. We'll start with a light pass of 20. All right, we're going to set up for the next diameter, which is going to be 325. So we've turned it down to 375. We're going to go to 325, and the length is going to be 0.225, 225 thousandths. So we're going to slow the lathe down just a little so we don't sneak up on that 225 thousandths distance too quickly. Looks like we're within about 3. We'll just go for 1. All right, 325 on the dot. And then the final one we have is a diameter of 313. So we need to take another 12 thousandths off. So we'll just come in. I'll take a total pass of 10. And we're only going this time 70 thousandths. All right, so we've made our initial setup here. And we're going to put that chamfer on that for 120 degrees. We're not quite touching the main body at 375, and we're just going to move it to the left until we get the angle about the depth we want. So let's give it a try. All right, we're set up here. We're going to be cutting it off at 912 thousandths. So let's go ahead and part it off.
Great. And this is the picture of everything all cleaned up. Thank you.